You see I've already put some color into some of these examples right here, so I'm just going to go into this very first one and explain what I've done here. So with this very first one, you see that we're multiplying together this particular factor with this other particular factor, and we're asked to simplify this. So right now it's not in simplest form. And of course we're going to be able to FOIL this. So really we're taking a binomial times another binomial, but what's unique about this is that we've actually used the same particular terms in the binomials, so hence the red colors and the blue colors. You can see those same terms. So really the only differences between these binomials is that in one we have addition or a sum, and the other one we have a subtraction or a difference. And so really what we are doing right here is we are actually taking ultimately a product, because we are multiplying these two factors together, but what we're producting is we're taking a product of a sum, because right here that's a sum of two different terms, and of a difference. And that difference, of course, is acknowledged right there. And so I'll bring this terminology back in just a little bit. And so when we do take a product of a sum and a difference, okay, so we're going to FOIL this. And when we FOIL this, you're going to get x times x, which is, of course, going to be x squared. And then when you take x times negative 2, you get negative 2x. And then when you take a positive 2 times a positive x, you get plus 2x. So, of course, by adding and subtracting 2x, it's just going to eliminate those terms. And so you really won't get anything out of that, but you will get something out of positive 2 times negative 2. You're going to get, of course, the subtraction of a 4. And so what we get as the result of a product and a sum and a difference will always be basically an expression where you've kind of eliminated those middle terms. And what we get right there is we actually get an expression that is a difference of a couple different terms. And in particular, that x squared actually came from taking x times x. And this 4 actually came from taking 2 times 2. So actually both the red thing that we got right there and the blue thing that we got right there came from taking the same thing with itself, which we call squares or perfect squares in math, right? So what we can really actually call that expression is we can call it a difference of squares because we got a difference of perfect squares. So that's something that you should kind of really recognize. And so like almost instantaneously, like when you encounter a problem where you see like 5 minus 3x and then 5 plus 3x, like you should just be able to anticipate that the negative 15x and the 15x in the middle are going to eliminate as part of the FOIL. So you should just be able to recognize like, okay, I'm just going to get 5 times 5 out of this, right? 25. And then I'm also just going to get the negative 3x times negative 3x out of this. So minus 9x squared. And lo and behold, we do get that expression that's a difference actually of perfect squares, since 25 is a perfect square as well as 9x squared is a perfect square. So we can just kind of generalize this to say that like if I have any sort of a thing and some sort of b thing, then generally what you're always going to get out of that then is you're going to get a squared minus whatever that b thing is squared as a result of that. So again, just emphasizing terminology is that right here, this is where you're getting the difference of those squares as a result of this multiplication that was happening right here. And this is where we had the product of that sum and that difference together with one another.